Okay, we're going to be looking at the non-calculator paper now. Something I would recommend when you watch these videos, I'll put all the links to the questions in the description so you can just fast forward to those particular questions. I'd also recommend at some points or regularly pausing the video, going back over things or trying things yourself when you've paused it, because that will make you think more during the review of your exam papers. You should also have the exam paper in front of you so you can see what you did on the questions and where you could improve. So we're going to look at question 1 now. Question 1 has the following sequence. It's told you it's linear, which means the difference between the terms is increasing by the same amount each time. We know that it increases by 4, so the next term will be 14, then 18, then 22. Okay. Write down the nth term. Well, it's a bit like the 4 times table because it goes up in 4s, so it's like 4n, but the 4 times table goes 4, 8, 12, so it's the 4 times table plus 2 more. Okay? Next, question B. We have this sequence. A handful of people mess this up for no good reason, really. Let's start. So we have the first term. The first term is when n is 1. This is 5 minus 3, which is 2. The second term is when n is 2. So this is 5 minus 3 times 2, which is 5 minus 6, which is negative 1. The third term is when n is 3. This is 5 minus 3 times 3, which is 5 minus 9, which is minus 4. So the terms, the first 3 terms are 2, minus 1, minus 4. You can see that it's a bit like the minus 3 times table, as it should be. It goes down by 3 each time. So the question then is this sequence linear? And the answer is yes. Why? Because there is a constant or a common difference between terms. That's what you might have written. Something along those lines. Something that said the difference between each term is the same. Anything like that would have got you the 2 marks there. Okay. Next question. So, it says work out the following, showing your working and writing your answer simplified. This question, well, we can times across, but we can also cancel before we've multiplied. So cross-cancelling gives, well, 6 and 8 have a common factor of 2. When we cancel those, common factor of 2, we're left with 3 and 4. And we can multiply the numerators to give us 15, and now multiply the denominators to give you 44. You could have just multiplied across to give you 6 times 5 is 30 over 88, and then simplify afterwards to give you the correct answer. Next question. When you add fractions, you can't add them unless they are the same. You can't have 2/7 plus 3/5 and get anything sensible unless they have the same denominator. The sensible denominator, or the lowest common multiple, would have been 35 in this case. So it would have been 10 35ths plus 21 35ths. You can work out how to do this, how to change it to 35ths. Well, to get from 7 to 35ths, I've times by 5, so I have to times the numerator by 5 to make an equivalent fraction. And this fraction, you've times the numerator and denominator by 7 to give you an equivalent fraction. Now that we have 35ths, well, if we have 10 35ths and 21 35ths, in total I've got 31 35ths. We can add them now. In part C, I'd recommend turning it into a top-heavy fraction first. To turn it into a top-heavy fraction, you're going to have 8 quarters plus 3 quarters, because you've got 2 and 3 quarters, which is 8 quarters and 3 quarters, which is going to be 11 quarters. 11 fourths minus 11 twelfths. Now we can't subtract them unless the denominators are the same, and the lowest common multiple will be twelfths. So 11 quarters is the same as 33 twelfths, timesing top and bottom by 3. Take away 11 twelfths, giving you a final, or an answer of 22 twelfths. Simplifying gives you 11 sixths, or if you want to write it as top-heavy, mixed number 1 and 5 sixths, but I personally prefer the 11 sixths option. Next. Write these as top-heavy fractions. So we could do, this is the same as 63 fifteenths, because 4 and 3 fifteenths is going to be 60 fifteenths and 3 more fifteenths, so 63 fifteenths, and 3 and 3 fifths, well, that's going to be 15 fifths and 3 more, so 18 fifths. Now, when we divide fractions, we turn them into top-heavy first, and you've already done that in the previous part. When you divide by a fraction, you will kiss and flip, as we've talked about, so it's going to be 63/15 times by 5/18. At this stage, I would highly recommend cross-cancelling. So the 15ths and the 5ths have a common factor of 5, leaving you with 1 and 3 respectively. The 18ths and 63 will have a common factor of 9, leaving you with 2 and 7. Timesing across will give you 7/6. This is your final answer. Just if you never quite worked out why we were allowed to kiss and flip, it kind of is an extension of the idea that dividing by a third, if you divide a number by a third, it's the same as timesing by 3. Okay, and timesing by 3 is the same as timesing by 3/1. So, for example, if you want to do 10 divided by a third, how many thirds in 10? Well, that's the same as doing 10 times 3. So it's kind of an extension of this idea why we can kiss and flip. And why we can cross-cancel, well, if you do 63 times 5 divided by 15 times 18, for example, the reason we can cross-cancel here, well, we could write it like this if we didn't actually do the multiplication, but we could also simplify 63 as being 9 times 7 times 5 as the numerator, and the denominator might become 3 times 5 for 15 and 9 times 2 for 18. So the common factors, there's going to be a common factor of 9 and there's going to be a common factor of 5. So cross-cancelling is a way of cancelling common factors before the end because I know they're going to be common at the end, so I just cancel them earlier on. So I know there's going to be common factor of a 5 earlier on, that's why I can cancel out the 5 and the 15 in the earlier part, and I know there's going to be a common factor of 9, that's why I can cancel 63 and 18. Okay? So if you were to cancel here at this stage, you cancel the 9s, cancel the 5s, leaving you with 7/6, which is the answer. Okay, this question, question 3. Very simple. We know that distance, speed, time looks like this in the triangle, so speed is equal to distance over time. In this case, they have gone 50 miles in 2.5 hours. 50 divided by 2.5 is 20. If you weren't sure how to do that quickly, you could have done, well, I know 10 into 2.5 is 4, and so 4 times 5 to get to 50 would give you 4 times 5 is 20. Another way to look at it is to look at the graph, how far has he gone in 1 hour. Using the red line I've drawn, in 1 hour he's gone 20 miles, so 20 miles per hour would be the answer. Okay, on which part of the journey was the car travelling faster? And it's from B to C. The reason is because it has a steeper gradient here. Okay, next. This family stay at the theme park for 4 hours and they take 2 hours to return home. So you just draw a line that's takes 4 hours, but it doesn't move, and then it goes down in 2 hours. Okay. Right, next question. So we have this simultaneous equation. I'll show you both methods, the elimination and the substitution. I'll start with elimination. So we'll label the equations 1 and 2. They already have, the y's have the same coefficient. And so if you do equation 1, take away equation 2, oh god, I'll go back, sorry about that. Okay, if we do equation 1, take away equation 2, then we will be left with 4x, because 9x take away 5x is 4x. We have y take away y, which is no y's, and 30 take away 18, which is 12. So we have 4x is equal to 12, which means that x is equal to 3. Now we're going to substitute x is 3 into equation 2 looks easier, so substitute into there. So we get 5 times 3, because it's 5x, plus y equals 18, and so y must be 3. If you use substitution instead, then you might have done the following. You might have rearranged equation 1. So equation 1 would become y is equal to 30 minus 9x. Then you might have subbed this, 30 minus 9x, into equation 2. So you get 5x plus y, and y is 30 minus 9x, and that's equal to 18. So I've substituted y is equal to 30 minus 9x into equation 2. Now I only have x's. I combine like terms to give me negative 4x, and then I'll take away 30 from both sides, and this leaves me with x is 3, as one would expect. And then you use x is 3 and find out what y is, as we did in the elimination method. Next question. Now this is a classic lower remove question. You have two linear sequences and then they end up being a sequence of fractions. Okay, so let's look at the linear sequences that we were asked to consider. This linear sequence goes down by 2 each time, so it's like the negative 2 times table, but the negative 2 times table would be negative 2, negative 4, so it's the negative 2 times table but 9 more. This sequence here is like the 7 times table, but it's not the 7 times table, it is 5 more than the 7 times table, and notice the mistake. When I was writing the paper, apparently I couldn't do 33 plus 7. Okay, so we have two linear sequences. Now notice how in this fraction we have the numerators look like the sequence minus 2n plus 5, and the denominators look like the sequence 7n plus 5. So that means that the sequence of fractions is just a linear sequence of numerators and a linear sequence of denominators. That's it. Okay, you didn't need to do anything else. You can't find common differences between the fractions. You've got a linear sequence as a numerator and a linear sequence as a denominator. Okay, you can't simplify this any further. This is it. Right, next question. This question looks slightly different on your paper. It had a big fraction line, and so I'll use that when I'm answering the question. It was basically taking your understanding of substitution, sequences, and division of fractions into one question. So the first term, well, that means that n is 1. So when n is 1, we have 1 divided by, well, 1 plus 1 is 2, all divided by 1 plus 2 is 3 over 4. Okay? So this is 1/2 divided by 3/4. 1/2 divided by 3/4, we can change this big fraction line for a division line. So this is a half divided by 3/4. A half divided by 3/4, well, is a half times by 4/3. So we can cross cancel here if we wanted to, and multiply, giving you 2/3. Okay, now that we've done that question, you might wonder, this might be a good time to pause the video and to work out what the second term would be. So the second term should be, well, when n is 2, so we have 2 divided by 2 plus 1 is 3, all divided by 2 plus 2 is 4 over 5. Now we have 2/3 divided by 4/5, which is the same as 2/3, times by 5/4. Cross cancel, leaves you with 5 times 1 over 3 times 2, which is 5/6. Now lots of people made the mistake in this question of writing 2 decimals as a fraction, so 0.75 over 0.75 for the first answer. Now 0.5 divided by 0.75, that's not a fraction. Okay? Fraction has to have whole numbers. Or it's not simple, at least. So you might have written this and then simplified your answer to be, I don't know, you might have said it's 50 over 75, and then this simplifies to 2/3. Now with the second one, people then might have written, well, this is 0.66 recurring divided by 0.8. Now this, again, you can't really have decimals in a simplified fraction. So you might have, if you did write this, you might have said, well, how can I make these whole numbers? Well, to make these whole numbers, it's not obvious, but if you were to times top and bottom by 3, well, we know that 2/3 times by 3 is 2, and 0.8 times by 3 is 2.4. Then you might have written this as 20 over 24, for example, and then simplify to give you 5/6. Let's just go back to that. Okay? So this would be how you could do this question. I think that dividing by fractions and then multiplying by the reciprocal is probably the best option. Okay, next question then. This question was mostly done well. Okay, so I'll go back a bit, I've skipped a step. Okay, so things to note in this question, it's the height of the waist above the ground, and he starts with his waist 3 feet above the ground. So he waits at the bottom for 1 second, and so we draw that little line in there. Fred then takes 5 seconds to walk up the stairs. Well, he starts with his waist at 3 feet, and he ends with his waist at 21 feet, because if you were to draw him there, his waist would be 21 feet above the ground. So we could draw a nice straight line because we know he walks at a constant speed. A couple of people made this mistake where they drew it only up to 18, and a couple of people also did it 5 seconds from the start, not it takes him 5 seconds. Okay, he then walks across to the edge of the platform, which takes 3 seconds, which would just be a nice horizontal line. He sits down, which takes half a second, so his waist will go from 21 feet in the air to 18 feet in the air. If you think about this, he would be standing at the edge and he would sit down. Okay, next, he waits in for 1 second. So carrying on, I got cut off in the last video. We were at the edge of the slide, and he'd sat down, and he waits there for a second, thinking about his fall. Now, when he does slide down, we'll think about the path he takes. He goes quite slowly at the start. His height doesn't change that dramatically, that quickly. And it takes him 4.5 seconds in total, so he doesn't change that quickly at the start. It goes quite slowly. Then it goes pretty fast, and then his waist stays at 3 feet towards the end for a little while with that flat bit of the slide. Okay, and if we were to draw that on the graph, well, I'll take that a bit slower. So he goes quite slowly here. He speeds up as he goes down the quick bit, and then as it flattens out, he goes to here. So what you can see, really, is that the path he takes when he slides looks a bit like the slide he slid down. And that's true of the whole question, actually. If you kind of squint your eyes a little bit, the drawing that we've made looks a little bit like the slide itself. Yeah. Lots of people drew a straight line for that slide at the end, and it should have been a curved one, and it was -1 point, so you lost a mark for each kind of mistake you made. So if you're not sure how it was marked, that's sort of how. Okay, we'll look at the next question, which is an algebra question. So in this question, question 8, most people expanded the brackets first, which is fine, so you get 9x minus 36 to the numerator, denominator doesn't change, and then here you get 12x minus 8 as the numerator, and the denominator doesn't change. From here, we don't like the fact that there's fractions, so we kind of want to get rid of them somehow. We might times both sides by 3, because timesing both sides by 3 will get rid of the denominator on the right-hand side. Timesing the left-hand side by 3 is like timesing it by 3 over 1. Timesing the right-hand side by 3, we could write it as the same thing, if we wanted. But notice how this is 12x minus 8 divided by 3, so timesing this side by 3 will cancel out that division, so we should just be left with 12x minus 8. On the left-hand side, well, we know when we times fractions, we times numerators and denominators. So timesing the numerator by 3 will be timesing 9x by 3, and then timesing negative 36 by 3, which will give you 27x minus 108. And then looking at the denominators, we've got 1 times 4, which is just 4. From here, you still have a fraction that you want to kind of get rid of, so you might times both sides by 4. Timesing by 4 will be like timesing by 4 over 1. And on the right-hand side, we don't really have a fraction, so we can just write it as timesing by 4. And because we're going to times both terms by 4 on the right-hand side, you might put this in brackets. Okay, so since we had 27x minus 108 divided by 4, if we times that side by 4, the 4's cancel, and we're just left with 27x minus 108. Expanding the bracket there, timesing both terms, we get 48x minus 32. Now we have a simple linear equation that we can solve in the usual way. We might add 32 to both sides to give you 27x minus 76 is equal to 48x. And then you might take away 27x. leaving you with negative 76 is equal to 21x. Dividing both sides by 21 will leave you with x is equal to negative 76 over 21. Okay. Right, now a different way to do this, a slightly quicker way, would be to realise that timesing by 4 and timesing by 3, which is what we did in the method we just looked at, is the same as timesing by 12. So we could times the whole equation by 12. Timesing the left-hand side by 12 would be the same as timesing by 12 over 1. Timesing the right-hand side by 12 will be the same as timesing by 12 over 1. Now we know how to times fractions together. We times their numerators and times their denominators, and we can cross-cancel if it's appropriate. So here, common factors on the numerator and denominator, there's a common factor of 4, sorry. 12 divided by 4 is 3, 4 divided by 4 is 1. And then looking at the right-hand side, the common factor is 3. So we can cross-cancel like that. Now we just multiply numerators together. So this will end up being, well, it's going to be 3 times 9, which is going to be 27 brackets x minus 4. So this is really 3 times 9 times x minus 4. You don't have to times it by 3 inside and outside the brackets. You just times that side by 3, times the term by 3. Gives you 3 times 9, which is 27 brackets x minus 4. The same applies to the right-hand side. It'll be 4 times 4 times 3x minus 2, which is going to be 16 brackets 3x minus 2. Now you can just expand the left-hand side and expand the right-hand side, and you get the same thing that we did before. Okay, so this is another way to do it, slightly quicker, I think, maybe more room for error if you make a mistake with your cancelling. Okay, and finally, we're going to look at this question, this simultaneous equation question. We're going to look at elimination, the elimination method. So, well, actually, I'm just going to look at the elimination method. Right, we need to make either the x is the same or the y is the same. Now, for me, I think it would be easier to make the x's the same. So I could times the equation 1, I could times the equation 1 by 5, giving me 10x minus 10y equals 30. Then I could times equation 2 by 2, giving you 10x plus 14y equals 14. Now, lots of people got to this stage or something similar. We might call this equation 3 and equation 4. And so I could then do equation 3 take away equation 4. The problem most people had was in this next stage. So 10x take away 10x isn't 0x, we know that. Negative 10y take away 14y. Lots of people wrote this as 4 or negative 4, but it's not. Negative 10y take away 14y is going to be negative 24y. And then the right-hand side, well, 30 take away 14 is 16. So lots of people got the previous part right, but then when they did the subtraction of the equations, they got it wrong. From here, negative 24y, well, that means that y is going to be negative 16 over 24. Simplifying this fraction leaves you with negative 2/3. So y is negative 2/3. We can now use this and sub y into, I don't know, equation 1 looks nicer. So we can write 2x minus 2 lots of y, and y is negative 2/3, so it's negative 2 lots of negative 2/3, and that's equal to 6. So negative 2 times by negative 2/3, well, that's going to be 4/3. Okay. Then we might take away 4/3 from both sides. So this is going to be 6 is 18/3, and 18/3 take away 4/3 is going to be 14/3. And then if 2x is equal to 14/3, you can divide both sides by 2. You could write the answer straight away as being 14 over 6. Or you could write it as 14/3 divided by 2 over 1, which is 14/3 times a half, cancelling. would give you 14 over 6, or if you cancel, you're left with 7 over 3 as your final answer. So x is 7 over 3. Okay, we'll leave it there. I hope that was useful. You should now go on to look at your calculator paper and using the same sort of idea, so pausing the video where appropriate, making sure that you have your answers in front of you.